just go ahead.
All right, sure. So I don't really want to give a very in-depth talk about like the theory behind lenses and whatnot. Can you guys hear me all right? Is that decent volume?
Yep,
Yeah.
it's good.
All right. But because there's a lot of good resources out there. Everett Kmet wrote or did a talk. It was a little bit high level, so it's kind of hard to get into. But Simon Peyton Jones did a wonderful talk. It's in the there's links to all this in the Lens library as well. But so I kind of just want to go over some examples and kind of give a little bit of motivation. Excuse me, because I feel like there's enough good resources out there that I shouldn't try to muck up somebody's understanding of it. So I went ahead and made a couple of examples and pushed them up to GitHub. And I'll just send the link right here. So I don't know if you want to clone it, you want to follow along, or should I share my screen to see what's going on, or how should we do this? A screen share, will that work?
Yeah, I think so. It could work.
Okay. All right, now how do I do that?
I think it's on the left, the green icon. If that doesn't work, I'll open it up and follow along for the recording. So.
Yeah, I'm not getting anything there. Is that working? You guys see that, or not yet?
No.
All right. Well, does that work? What does that do? Did that do anything? No? All right. I don't know what's going on. Okay. So it's going to be kind of hard to follow along with, I guess. So if we look at the first module there, let me just give a link here. Samples, optic. So if we look at this first module here, this is kind of like the canonical example for lenses, where you have some nested record, and usually people do like a person record, right? So you have some nested record. It's got a person, an address, a street record, right? So it goes down pretty deep. And actually the reason that they're wrapped in new types rather than just being type synonyms is so that we can define show instances for them, so that you can load this up in the REPL and you can just run it and you can see the outcome. So we've got this person type. Yeah, it's person new type. It's a new type over a record that has a first name, a last name, and an address. The address is a new type that has a street, a city, and a state. And, it keeps going, right? Above that, there's a module that has the states and the designations and stuff like that. So just to kind of get it a little bit clearer. So then you have you have some show instances, and then you have just an example person on line 170, John Doe. Is that good, or you guys following me? If anybody has any questions, go ahead and stop me mid-sentence and just yell at me, because I know I talk kind of fast and sometimes it's not very clear. So you have the example record of John Doe, line 170. He's got a first name, last name, address, all that kind of stuff, right? So if you were doing this just normally in PureScript and you didn't have lenses, you just were going to, choose the regular stuff you got, you can use, if you wanted to change the first name on line 187, you have a function that takes a string and a person and returns a person, right? So you get the new name, you pattern match on the person to get out the record P, and then you just return a new person where you update that one field first name to the new name, right? That's pretty normal stuff. Not too, if you're just doing one level of nesting, you're not really, there's no real thing that you get out of lenses, because it's fairly clean in PureScript. It's a nice syntax, right? But if you need to go down and do something that's nested for changing the state, we've got on line 190. So you're getting a new state, Arkansas or California or whatever, right? and you want to update that field in the person. So you have a function that takes a state and a person and returns a person. So same thing, you pattern match on the person to get out the person record. And then when you go to update it, well, now you've got to reconstruct the address after you've deconstructed it, right? So since it's a new type, that sounded kind of confusing. Since it's a new type, you have to unwrap that address new type, right? So that's why you have, run address over p.address, and then you set the state to new state, and then you wrap that all back up into an address, right? So this is pretty confusing. It's kind of hard to see what's going on there. And then if you need to go even deeper, this is like example on line 194, the change street number. You've got a number and you got a person, and you want to update the street number of that person, right? So again, you pattern match on the person, and then you need to go into the address and then the street and then the number, right? So since we have these other new types, then you have to unwrap the address new type again, and then unwrap the street new type, and then finally change the number, and then wrap it back up, and then wrap the address back up. And it's really hard to kind of follow what's going on. And if you try to do it all in like one line, it looks like hell, because you're trying to it's just terrible. So you can do like some local definitions and a where clause or whatever, but it's still kind of you just kind of don't see what all's happening, right? It's a little confusing. So the idea of lenses comes along, right, where you have some way to I guess I kind of should have went over that first. So the problem, this is the problem we're trying to solve, right, is that updating a nested record in a language like PureScript or Haskell is a pain in the ass, and it's easy to get confused. And if you've got some crazy looking type like the person type, then your errors are going to be horrible to read also, right? So the idea is that you have a lens into a structure. And what a lens gives you is it gives you a way to get a value and a way to set a new value at some point within that nested data structure, right? So so if we were to rewrite the, let's see. Let's go over some of the lenses here real quick. Maybe we should. Okay, so just converting each example straight over from standard syntax over to lens syntax, you would have like the change first name lens, where you're doing the same thing. You're taking a string and a person, and you're updating the person field. So you just set, and you have a lens that unwraps the person new type. That's the underscore person. And then you have a lens that goes into the first name of the person record. That's that person. First name thing, right? So the dot in the middle is just regular function composition. It's just an alias for the triple left angle brackets, right? So it's just standard function composition, right? So if you need to set the string in a person, you just say you want to set underscore person dot first name, right? Seems pretty straightforward, seems pretty easy to go with, right? Well, when you need to do the next one, the change state lens, you get the state, you get a person, you want to update the person, right? So you set, and then your lens that you're constructing there is unwrapping the person, that's underscore person, going into the address, that's the address part, and then unwrapping the address new type, that's the underscore address, and then going into the state, that's the state one, STAT. So, this looks worlds better than the change state example in line 190, right? Because it actually looks like you're just saying, person.address.state, right? You have a little bit of wonkiness with the new type wrappers, but I don't think you can get around that, right? So then the real place where it shines is the third one, the change in the street name, the street number, because instead of this crazy stuff that's going on line 194, you have what looks like just regular function composition, right? It just looks like you're just saying set the person address street number, right? You have to unwrap the new types a little bit, right? You got your person unwrapper, you have your address unwrapper, and your street record unwrapper. But it reads very cleanly, I guess. Yeah. So it's a lot easier to understand what's happening in change street number lens than I would say in change street number. Right? Does that make sense? You guys following along, or any questions?
Can you hear me?
Yeah.
So just to clarify, the first name and address and state functions, those are themselves lenses. Those are not just like getters for that field.
Right. So for those, if you scroll down, starting at line 219, those are all the lenses that we're using in the
Okay, I see the
module here. Sorry. So and actually, I'm using wildcard syntax there, so you can't actually tell what their lens is from and to. But I think I have some other examples that, well, maybe I don't. That wasn't very good. But so your person lens is a lens from the. I probably really should have done wildcard syntax there. So the person field is a lens from the entire person data type down into just that record that has first name, last name, and address. Right? Does that make sense? And then same with the address lens and the street record lens. Their lenses from addresses lens from the address new type down into the address record. Street record is a new type, or I'm sorry, a lens from the street record new type down into the street record, right? And so for first name, that's a lens from a record with a first name field down into the actual string, right? You know what? This is going to be really confusing. Let me take a second and just update these to have the actual values, and then I'll push that up. Is that fair?
So another question, actually.
Yeah, go ahead.
This would be rather boring to write out manually. Is there anything that would anybody automatically generate like a set of lenses for any data?
So last week, or not last week, the last meetup, we were talking about that actually, and I didn't look into it too much. But Phil, do you think you could mention what was going on there for a second?
Yeah, sure. So we were talking, I think, about the equivalent in PureScript of the template Haskell approach, right? Where in the lens library in Haskell, you would say something like derive lenses and give a type, and if it was a record, it would pull out the record constructs and give the lenses for all the record members, things like that, right, Hardy?
Yeah. Yeah.
So we're saying we have a couple of options for that. We could either wait for like something like template PureScript, which is probably a couple of releases away realistically, and do the same thing, or we could write something like a gulp plugin, which would do code gen on. So you'd pass you'd pass a module to some gulp plugin. It would parse the PureScript, figure out the types, and output another PureScript module, and that would be a part of your build process. So slightly different approach, but the question is, how do we do code gen? Do we do it via template Haskell, or do we do it via gulp or grunt or something? But I think it's definitely doable. And going back to your comments about deriving show, I think that's a way we could do that as well. We could have a deriving show gulp plugin or a deriving show template PureScript, quasi-quota.
Does that kind of answer your question, Michael?
Oh yeah, definitely.
Okay. All right. So I'm just going to do a couple of these, just so that we can kind of see what I'm trying to say. So I'm not just saying just words. But let's make sure that compiles. Good. Let's give it. Okay. So I just updated that thing. So if you refresh your screen, or if you pull, I don't know if you cloned it or whatever, but if you look at the, if you look at line 219 now it's got the type, and actually I'll just copy and paste this in the thing as well for it. It's got this type here, which looks hideous, right? But all it's saying is that it's a lens from the person field, or the person data type, whatever that is, down to a record that has a first name, that's a string, a last name that's a string, and an address that's an address, right? So what that means is that this function underscore person gives you a way to view that record in a person data type, right? Which is kind of confusing. But if we also look at, say, the first name lens on line 228, it's got, say, this type right here, right? Where it's a lens from a record that has a first name field that's a string, and the R means there's some other, possibly other fields in this record, and it lenses down. It gives you access to the string part, right? Does that make more sense as far as like what the types are doing there and what the functions are? No, you all just go.
That explains it pretty nicely, I think. Yeah.
Say again.
That explains it pretty nicely, I think. It just expands out the new types, and the others are like accessory methods.
Yeah. So, as far as like creating lenses, and I mean, I think this is the part that really kind of throws people for a loop, is what is this actual type, this lens P type, right? So, it's a type synonym is all that it is, actually. Like it's not a new type, it's not a data type, it's just a regular old plain type synonym, right? So what that means is that if you wanted to define a lens, you wouldn't actually need to depend on the lens library, since it's just a type synonym. There's no actual dependency on the synonym, right? You just need to depend on what it's a type synonym for, right? So if we look at, let's see, where is the types? If we look at this file here, this shows us the types of the more general lens that has 4 parameters and the less general, the more specific ones that only has 2. So what this type is, you've got the stab, the lens stab, right? The STAB. It is a rank 2 type over a functor, where the first argument is a function from A to f of B, and then it takes an S and gives you an f of T, which is really confusing, right? So if you want to understand like the reason behind this type, because it seems like, I mean, you just pulled this out of your ass, right? If you just look at it, you don't think that somebody's just going to arrive at this, right? But if you look at the talk from Simon Peyton Jones, he does a real good derivation of how you come to that type, and it makes sense once he goes through it, right? So I guess my point here is that the type looks wonky, but it's wonky for a reason. And since it's just a type synonym for functions like that, this is why we can use the standard function composition, the triple left caret or the dot, right? So looking at, say, which one of these? Person, right? Looking at the underscore person field, or lens, in the example on line 219. So it's a lens P from person to that nested record, right? So lens P is, it makes the first 2 arguments the same and the last 2 arguments the same with a lens, right? So that would have the type for all f constrained by some functor f. You take a function from A to f of A and return a function from S to f of S, right? So when you're defining it, you can define it with taking the function and then taking your S. That's the function is f in the example, and the S is the person of B, right? That's your band metronom. And then you just apply the f to the B, and then you map over that and get the person there. It's a little confusing to understand what's going on, but if you follow the types, it just kind of lines up. But if you don't feel like doing that, there's always the standard lens function there, and you can just pass in the getter and the setter, right? So there's a couple different ways to construct it. Of course, if you do it this way, you have to actually depend on the lens library. If you don't do it with the lens library and just use regular functors and stuff, then you can write a lens without depending on the lens library for anybody else that might use your library and also use lens at the same time, right? So I think that's kind of neat. as far as the kind of theory behind it. Does that make sense? Was that too confusing? Did I go too fast? Did I go too slow? Are you even still following?
I think that's great. Thanks. Sorry, I'm on mute.
Okay.
So.
I have one question.
Yeah.
What is the more general lens type? What's the advantage that it gives you over
Right. Yeah, sorry about that. So if you have the actual lens with the 4 parameters, the S and the T don't have to be the same, and the A and the B don't have to be the same. So what does that actually mean? That means that if you have, let's see, if you had like the first name lens, you could have a lens from a record with a first name that was a string, and it would lens down to a string, and then your function might change it to like a Boolean or something. And then what you would return is a record with a first name field that's a Boolean. Does that make sense, or should I expand the type out a little bit? Like in the repo.
No, I think that's fine. So you can apply a function to the value that you're actually getting.
Yeah.
All right. Okay.
So it gives you kind of it sort of gives you a way to, yeah, that's it. Yeah.
It sounds like a getter function in Java or any other oriented language where you can change something about the thing that you return, right?
Yeah, exactly. So,
thanks.
So, yeah, no problem. So with these general type synonyms, since the F is not constrained by the lens itself, you can choose a different functor, and you'll get a different sort of optic type of thing, right? So for lenses, well, no, depending on what you use. What this means is that if you give it like, and this kind of relates to what we were talking about the other day, or last night, Phil, is if you give it a identity functor, then it's going to behave in a certain way. If you give it like a const functor, it'll behave in a certain way. If you give it the maybe functor, it'll behave in a certain way, right? So that behavior is dependent on whatever functor you give it, right? So if you look at line 214, you have a getter, which is, I mean, it's like it sounds like in Java. It's like a getter. All you can do is access the field. You can't actually update it, right? But the type of getter is still like a similar type to a lens, right? It's got some slightly different constraints, but it still has basically the same kind of structure, right? It's a getter SA, and it's constrained by a contravariant functor and a regular functor. And the A, it's a A to FA, S to FS. So you can't change the type of the thing, right? But you also can't set anything within the structure. And I think that comes from the contravariant and regular functor part. I'm not entirely sure. But so what that means is that if you try to use full name to set, you will get a compile time error rather than a runtime error for using the wrong thing, right? So you can still get the full name value, right? And this is kind of it's sort of like I forget what you call them, but like in Backbone they have like a way to like pretty up the model type or something like that. So it's sort of like that, but a getter just allows you to get a value out of a data structure. You can't set the value in the data structure. And the good thing about having a type synonym for it that has a slightly different type than a regular lens is that you can say that you can only use it for getting. And if you try to say like, set person or set full name to some string in a person, then you'll get a compile time error that says the types don't match up, right? So I was hoping with a screencast I could actually show this in the REPL, but if you load it into the REPL, you can just try it, right? You can try to either view the first name of John Doe, and it'll give you, or the full name of John Doe, and it'll give you, a pretty printed name. and if you try to set it to some value, then it'll throw up a type error, something about identity or something like that. So something doesn't line up. But so I think that's kind of cool, right? Because you basically you get a little bit more static analysis for free, basically, right? By just slightly altering the type. And so as far as like the implementation of that, it pretty much just falls out of the types as well. So if you just kind of follow the types, it makes sense to have like the const at the end and all that other stuff. As far as that p.first name plus the empty string plus p.last name, that's just me using full name as a prettier version of the name, right? So if we're all good there, then I'm going to move on to some, because like, for lenses, the initial example is usually a nested record, right? But there's other things that you can do with it. So I was actually watching the Simon Peyton-Jones talk last night to try to get some ideas, and one of the things that he mentioned was that you can have invariance within the lens, right? So if we move on to the bounded example, that's the module right below it, this one right here. You can specify an invariant, and what I'm doing here, I've got a new type ball, and again, it's a new type so that we can show it. And I've got, say, some bounds. Like I want the ball to be bounded within this 100 by 100 rectangle, right? So I've got this function here, or I've got a couple of values, min x, min y, max x, max y, right? From 0 to 100. And then I've got this function clamp that takes, and I just use a couple types in here, lower bound, upper bound, and a number. So it keeps it, if you try to set, it's just a clamp function. If you give it a lower bound and your n is lower than lower bound, it'll be set to the lower bound. If you give it something that's out of the, if you give it something out of the range, it'll just be set within the range. That's all that's going on there, right? So then we just define a couple of lenses here. We've got the underscore ball lens to unwrap the new type. And then we've got the lens for the X field in the ball record. So what this is doing is it's applying the function like normal, like a normal lens, but when it goes to set the value, it's clamping it between the min x and the max x, right? So if you pass in a function that would set the x to something above 100, say, like if you just wanted to set it to 105 or something, then it's going to clamp it down to 100. So you gain the ability to specify an invariant within the lens itself. So you don't have to go around and say, ball or set ball 106 and then clamp 106 or whatever. You know what I mean? Like you can just say set ball X to 106 and it'll just work out, right? So again, this was another example I was hoping to show in the REPL. But maybe I'll upload the examples after the talk and then we can kind of play with those as well. So I think that's kind of cool. Does that make sense as far as like the invariance and what clamp's doing there within the lens itself?
Yep, that makes sense. Thanks.
Pedro has a question in the chat.
Say again? I'm sorry. So that's just fmap reversed. That's just flip. Right. So you just put the functor on the left and the function on the right.
Okay. Thanks.
All right. So are we good with the bounded one? The bounded example?
Yep.
Okay. So then the next example, the virtual one, that's this guy right here. This was another thing from Simon Peyton-Jones' talk, where you can sort of mock extra fields. Like you can fake that you have more fields than you actually have, right? So we have a couple of type synonyms. This is for like units. We've got millimeters, centimeters, meters, inches, and feet, right? And then we've got this new type, length, that just wraps millimeters, right? So we're saying that the canonical representation of length is millimeters. And again, it's a new type so that we can show it. And there's an example length, a 10 millimeter length. It's just defined like normal. And then we have a lens into the new type so that we can unwrap it. And then we have a couple of lenses from, and actually I gave good types here. So we have a lens from length to millimeter, which is just standard lens. And then we have a lens from length to centimeter. And then same with a lens from length to meter and length to inch and length to feet, right? So you can keep a base or a canonical representation of some data type and then provide these lenses that sort of trick you into thinking that your length data type has all these extra fields where you can view it as centimeters, you can view it as meters, you can view it as inches or whatever, right? So, and actually this is really just an isomorphism. So it should be defined a little bit differently, but I didn't want to pull in the extra dependencies for this. So you can define it with just a regular lens, right? And then the way you define it is when you're applying the F, you first convert it to the value you want, and then in the mapped function, you convert it back to the other one. So like in the centimeter example, you're taking the millimeters and dividing it by 10, and that gives you like, if you had 10 millimeters, then you would have 1 centimeter, right? And then in the mapped part, the right side of it, you're taking the centimeters and converting it back to millimeters. So you're just multiplying by 10, right? And you can just use the standard unit conversions for that, centimeters, meters, inches, and stuff like that. Excuse me. So what that gives you is like you could say 10 millimeter. You view 10 millimeters as a meter, right? And it would return the 0.01 or something like that. If you say view 10 millimeters as inches, it gives you whatever, right? I don't know what that converts out to, like 0.3 some. But so it's just a way to kind of fake these extra fields on a data type. And you can imagine that you could do more interesting things with this. Like, sort of like the example of full name, you could have a faked field where you join a couple of fields together, and then you can get and set by like ripping them apart when they come back in and then putting them back together, right? So the full name one could be a lens if you join the first and last name together, and then you split them back apart when somebody tries to set, right? So somebody would give you like Jane Doe, and then you would split that into the first name and the last name, and then you would set those in the first name, right? So it's kind of interesting. Like you can kind of just mock these extra fields in a data type that only has one or something like that. So that's kind of the other example that I liked from Simon there. Did that make sense? Was there anything that was confusing about that?
No, I
think that makes sense.
Pretty neat.
Okay. And then the last example that we have here is an example of traversals. And actually, this is kind of like 3 things shoved in at once. Because it's got traversals, it's got prisms, and it's got this other index thing. So the idea is you have some terrible-looking data structure, this foo on line 338, where it's a list of tuples of either number, maybe string, and then maybe Boolean. And, you've got an example here. So it's got 5 fields in here. And, they're all different kind of types, right? So the values underneath them, the bar, baz, quux, all that stuff, these are actually taking the foo data type and performing some operation to update something nested within it, right? So the first one maps over the list of foo, goes into the first part of each tuple, then goes into the rights, if they exist, and then inside the rights, if there's a just, it's going to add whack to the end of it, right? So if you run this, your third and fourth entries in foo will be tuple right just 3 space WAT, and then tuple right just 4 space WAT, right? So it doesn't touch the first and second one because that single underscore right is a prism that only goes into the right stuff. So the first and second one don't change. The third one doesn't change because the nothing isn't a just, right? That's another prism there. And it's kind of interesting that you can write this this lens here that's, or this traversal that's very straightforward looking, but it just kind of works in the end, right? And so, I mean, I guess I kind of should have explained what the prisms are. So there's kind of a duality, right? You have sum types and you have product types. So if you have a product type, do I need to explain that? A product type is like a record or tuple, something like that, right? And then a sum type would be like either, or when you define a data type, the pipe that you put in there, that makes it a sum type. So for product types, you create lenses. For sum types, you create prisms. And that's really all there is to it, right? So when you have a data type like maybe, it's a sum type because it can be nothing or it can be just A, right? So when you're trying to use these optics, you want to use a prism for maybe, so that you can say, do something to the nothings or do something to the justs. And that's what you get here. You've got the single underscore just, and that's a prism into the justs of a maybe data type. And the same thing over here for rights. Either AB, you can be left A or right B. So you have a prism into the right side, that's the underscore right, and then you have a prism into the left side, that's the underscore left. And
Barty,
yeah, go ahead.
can you go into where each of these functions is defined? Like, where would I find mapped or underscore one or underscore right or plus?
Sure. Sure. Let's see. So mapped. Most of the setter stuff is in here, and in particular, mapped is this guy right there, and then the kind of line noise crap that you got going on there are just a bunch of functions that look semi-imperative. You know, you've got like the plus tilde, which kind of looks like, if you kind of squint a little bit, it looks like you're saying, you know, some data structure plus this thing. And then same thing with like the times tilde, it's something times 5, right? It's a little easier to squint at if you're using the monad versions, because it's like plus equals something, you know. I should probably put a better example in there of that. But so all it's doing is it's a setter for a specific type. Like the plus tilde setter is, if you look at the definition, you're just setting some field, but you're adding something before you set it, right? So you could define this by hand as a lens or whatever. It's just provided as like a convenience function for you. So there's a couple of the standard ones. There's plus, minus, times, divide. You get the Boolean ones, and then you get some semigroup stuff. So it's just, it looks a little hairy when you first look at it. And if it's a long line of stuff, it's like, I don't know what's going on there, right? But once you kind of get used to it, you kind of look at it and say, oh, okay, so this is that, this is that. But there's also just the regular English word versions. There's set and over in the same module there. And they do the same thing, they're just not infix, right? So sometimes it's a little easier to read when it's infix, sometimes it's not. Like in the original example for like changing the person first name or whatever, that was using set. But you could have also just used the dot tilde, right? So they're the same function, and I think they're actually defined. One of them is defined in terms of the other. So it's basically the same thing there. Is that out there?
Mostly.
I'll admit it's pretty hard to kind of understand what's going on here just first looking at it. But the more time you look at it, the more you say, okay, this makes sense. Right? It's just a familiarity thing. I mean, sometimes I look at myself and know what's going on. And there was something else that you asked. Was there another part to that, or did I answer all your questions?
Basically, was wondering like where the most appropriate place to define each of these lenses is, if it's in like the lens library in general, because these are like standard data structures, or if each data structure should define its own lenses and expose that, or if they have like a sub module like dot lens for each of these data structures, something like that.
Right. So the few that are defined already, like the tilde ones, and then in the extended functions, the equals ones, those are defined because they're very useful, and it just makes more sense to have them come with the lens library itself. But some of the other stuff that's not necessarily, like, you're not necessarily going to use an either prism whenever you import lens, right? You probably will because it's a fairly common data type, but you might not necessarily need like a tuple lens or something, right? So I broke those out from the library and put them into this one right here, this refractor, where the idea is that rather than writing all these lenses and prisms yourself, there's a centralized repository for some of the most common ones. And I really haven't done much to it. So if you find that you've written a lens and you want to share it with somebody, maybe it's got a really general name like name or string or state or something like that, then submit a pull request and we'll merge it in there, and then somebody else doesn't have to write a lens for it later down the line, right? And you also get to clean up your library by not having random lenses defined wherever. So, I mean, this library kind of goes back to the point that I think you asked before, and that Phil kind of talked about, where it'd be nice to have a way that we didn't need to write these things by hand, right? So if we look into the one idea the guy had with the kind of meta programming type deal, that might make this library go away, you know. But until somebody takes the time to do that, there's options for this, right? And that's where you actually get the just and the left and the nothing in the right, right? So those are all defined in this module here. So does that kind of answer your question? Oh, and then you asked about where should you define them. So if you, it's kind of like an opt-in thing. You don't have to write a lens or prism for your data types, but you can if you want to. It's like a no harm, no foul type thing. Well, for prisms, you actually need to depend on at least pro functors, or you can just depend on the lens library to get the stuff. But if you want to allow people to use your data types with lenses, then you can just write a lens for it, and then you can be good to go, right? And if you don't want to do that, then you don't have to do that. So if you expose, well, I guess it sort of depends. If you have a data type and somebody is using it downstream, if they can access all the fields on it, they can write their own lenses. You're not required to write a lens in the same module as where the data type is defined. Like in this prism one, these are prisms for either and maybe, and I haven't touched, I haven't touched prelude, I haven't touched purescript maybe, I haven't touched purescript either. These are just additional functions that you can use as prisms, right? Does that make sense?
Yeah, that definitely makes sense.
Okay. So, not sure what else I need to talk about here. I can kind of go through the rest of these examples. The BAS one, it does sort of the same thing. I'm sorry, we're back in the original examples here, line 348. So it goes over foo, and it maps down into the first field of the tuple, and then the left field if it exists, and it just multiplies by 5. So this would change the first 2 entries in here, so that the left one would now be 5, and then the left 2 would now be 10, right? But the rights don't get touched at all. Kind of interesting, right? So then the Quux example, it's doing kind of the same thing, mapping down, going to the second field in the tuple, going over the justs. So if they exist, then it's doing this modification. That's kind of it's supposed to be a little catchy thing that Ed came up with, the % mod thing, yeah. So anyway, it's modding over that, and it's just a regular function. It takes in a Boolean. If the Boolean's true, then the value becomes yes, and if it's not, it becomes nope. So that's going to go in and change the third and fourth ones, the last just in there, and the first one's going to be yes, and then the second one's going to be nope. Wibble, kind of doing the same thing. It's going down, and it's just counting the length of whatever's in the right justs. So that one's, I mean, they're pretty much the same. These last two, the wobble and the wubble, those are using the index library, and that is, that's this guy over here. So what these are doing is they're indexing into this array of foo, and for the first one, wobble, it's indexing into the first element, or I think it's zero base, so the second element, whatever, and it's changing the entire thing to this function what. And now, actually, this should be able to be written inline, but the types kind of blow up in the compiler, so you have to specify the whole type for whatever you're trying to update. So that's why it's separated out, so that we can give a type signature. I mean, you can do it inline, but it just looks like crap. So that one will go into the first, or in index 1, and change it to this what thing. So it's going to be a tuple left 12 nothing, right? That's going to be the second element in foo. And then this wobble one tries to do the same thing with index 100, which doesn't exist in foo because foo only has 5 elements. So the index function is ix. It's actually a safe indexing. So if you try to index out of bounds, nothing will happen. So basically wobble was just foo, right? Because there's no 100 index, so it doesn't set anything. There's no runtime error. There's no compile time error. It just tries to do the right thing. That make sense?
I had a question about
oh, sorry, I'm not even reading the chat here. Oh, sorry, go ahead.
I think we've been following the chat. On 349, that the function from B to a string, I don't understand. Is the data structure different that it's producing?
Yeah. So, like, if you look at the type of foo, it's a tuple where the right side is a maybe Boolean. But so since we're going down to the second part and the justs, and we're changing them from Booleans into strings, the new type of, well, not new type, the type of quux will be a tuple where the left side is the same. Or the first field is the same, and the second field will be a maybe string, right? So we can do this kind of an update because we're changing the justs. The nothings are still going to be nothings, right? But then instead of being nothings that are maybe Booleans, they're going to be nothings that are maybe strings. Does that make sense?
Yep, that helps. Thanks.
Okay. So interestingly, if you didn't use underscore just and used underscore nothing, you couldn't actually change the type because you would have other values in this array or list or whatever that still are maybe Booleans. Does that make sense? So if you tried to change a nothing into like a maybe string, you would then be trying to make an array where one of the fields was a maybe Boolean and one was a maybe string, right? So doesn't type check there. So you get a compile time error rather than like a runtime error or something. And then, okay. So, I mean, that's pretty much all that I wanted to share with you there. Are there any, did I explain things well? Was it a decent set of examples? Would you like to see something different, or any comments, questions?
I think a composed getter would be nice.
Okay.
For example, getter that shows a string representation of the street, for example.
Okay. Yeah.
Just something I thought would be nice to see in the middle, but in overall, it was great. Thank you very much.
Cool. Glad to hear that. All right. Well, I mean, that's pretty much all that I had. If you have any questions, just send them to me on IRC or on Twitter or whatever.
Hey, Hardy. So thanks, first of all. That was really great. I had a sort of question for you. Just wanted to see what you thought about it. So thinking about the deriving lenses thing again. So in Haskell, it's like, we deal with records where, they're not extensible records by default, right?
Right.
They're closed records, and the constructor is associated with some set of fields, and you can generate a lens for every field. But in PureScript, we have extensible records, which means that, we could be using anything from an infinite set of possible labels, right? And we can't generate a lens for every possible label. So either we go through and we sort of look and try and statically find all of the record field names that are used inside a module and generate lenses for those, or we go the refractor route, right? And we just sort of like try and pick some standard names and generate those ahead of time or something. But did you have any ideas or thoughts on like what, how we might go about code genning something like that from like a practical point of view?
So you say we can't generate them on the fly. Well, so if they're extensible, can't we just say like they've got the extra records in there, or the extra fields in there?
Yeah. So the problem, I guess, is that you don't have like polymorphic labels, right? Where you can't say something like this has a type for all labels. It's a lens from the record that has that label with some type of value and a row. You have to fix the label, right? You can't quantify over a label. So
yeah.
So either we have to go through the module and figure out all of the labels, or pick some standard names or something. So that's kind of annoying.
Okay, so this metaprogramming thing that the one person had created, you just apply like a string to it, right? And then it kind of does its thing.
The example, the Hatter example, the gulp plugin. Yeah. So what that was doing was it was actually a parser and pretty printer. So there was a language that it would parse, and then it would it had an internal AST type for PureScript, like a reduced subset of PureScript, and it would generate code for PureScript code that would then like feed back into the build cycle.
So if we have the AST for a record, then don't we have all the fields that are in the record?
Yeah, so I think practically, you could go through and like look for every time you say something like, you look at all the data type definitions, and every time a record appears, you look at all the statically defined labels in that record, and you define lenses for those.
Oh, are you trying to just have it work for everything that's in there, or do you want it to be like the Haskell version where you specify the data type you want lenses for?
Well, I think either, right? I mean, like one would just probably call the other. But at least, like to begin with, I'd like to point at a data type and have it generate lenses or traversals or something for all the sensible things in that type. So I don't know. I don't know what the best option is. Maybe we just go through and look for like sort of statically defined labels that appear in ADT constructors or something.
Yeah, that seems like probably the best way, because those are the only ones you really care about, right?
Mm-hmm. I think so. So another option that you could do is like if we had something like template PureScript, is that you could write a splice that like you gave it a string, and it would generate the code for the sort of the polymorphic record accessor for that label. So you would say sort of something like make label lens of the string foo, and it would have type, a lens from a record for all A and R, the record that had the label foo of type A and row R lenses down to A.
Right.
So like that'd be pretty lightweight, right? You wouldn't have to, again, like you say, you don't need to import the lens library. You just, you just write the type out, which only requires functus or prelude, and it would just generate, the thing with fmap that you had in your examples.
Yeah.
So at least for record labels, that could sort of like make things a little easier.
I feel like that's something we could do right now, right? Because we could just pass that down into the FFI and let it just.
You could definitely do it with the FFI, yeah. It'd be unsafe, but you could definitely do it. And maybe that's like the quick way to get it working, and then like wrapping a gulp plugin around that should be pretty easy, right?
Yeah.
So yeah, I'm interested in the code gen side of it, definitely. I think that'd be really neat to have.
Oh, I agree, because writing these lenses by hand is kind of a pain in the ass. I mean, if you can like copy and paste, it's a little easier, but and it's just like extra headache that you don't need. You know what I mean?
I was having a question.
Okay.
Or like an idea. Could lenses be a way to access fields on foreign values? So if you have like JavaScript data structures, if you want to interop with a JavaScript library, could you write lenses that access, like with the FFI, that access fields inside of the foreign data? So you don't have to import it into PureScript for like, maybe just, you don't want to write up every type that the JavaScript library already defined internally? Yeah,
that seems like something you could do. You would just have your lens would be from your, like if you had some foreign data type foo and you wanted to get like some string field, then you would just have a lens from foo to string. Does that make sense?
Yeah.
Yeah, and then you just define it however you actually define it.
Or could I do lenses that operate on foreigns and use the like foreign data type, which has the instance read, and then could I like chain the either through there, because the parsing of the foreigns is an either, right?
You have like a PureScript foreign lens library or something. That'd be kind of neat, actually.
I think I don't really know. It's some kind of thing, but yeah, you could definitely do that. There's nothing stopping you from doing that. That's something I probably should have mentioned before, is that one of the big things that really comes from this is that you can make a lens for any type and use it with anything, right? You're not restricted by the type needing to be, the type doesn't need to have a certain kind, I guess. Like for functors, you can only define functors for certain things, right? You can only define a functor that has at least one type variable. You can't define a functor for something that doesn't have an extra type variable, unless you wrap it in like a new type and do some stuff with it. Well, then you can't really do it either. But so you can define a lens for something that's monomorphic, right? You can have traversals that are monomorphic. You don't have to have a polymorphic type in order to use a lens. That seem right?
I'm actually kind of interested in this from for the compiler as well. Like, you know, when we started, we were using like SY scrappy boilerplate everywhere, and it was pretty slow, but it was neat. The code was neat. And then we moved over to handwriting a bunch of traversals, and I think at some point, Hardy, you pointed out, you know, these are starting to look quite a lot like lenses.
Yeah, well, a couple of them are lenses.
Right. Or traversals or something, and like, you know, maybe that is the answer. You know, I know we're sort of like, I mean, I'm sort of committing more and more to not implementing PureScript in PureScript and rather going like the GHCJS route, and you know, whatever. We can talk about that separately, but like, if we're going to like use GHCJS and GHCJS can compile lens, then why not use lens? And like, you know, why have this gigantic library of handwritten traversals? Why not write out our traversals using lens?
That's actually a good idea. You know, we could we could just have like a plugin for Run or Bolt that just used GHCJS with template Haskell to create the lenses, right? Seems like something that could happen. Or no, I guess it couldn't. Well, maybe. That's interesting.
Well, I'm just thinking of actually. I'm just talking about using the Haskell lens library at this point to tidy up the compiler source code.
Right.
But yeah, it's definitely interesting. Okay, so I'm probably gonna stop recording unless there's any other questions. Oh, all right, I'll stop.